All right, so the first step in doing a straight line motion problem is listing your facts. Now, you don't have to write out the word list the facts like I have in my notes. Just put them down. So if I'm listing the facts, I'm going to read the problem, and I'm going to stop when I get to a fact. Now, one thing that you should see when you're doing this is if something has units, it's probably a fact. And notice this is in meters per second, that's in meters per second, and that's in seconds. So there's only one option for the number that's in seconds, and we've got velocity that's measured in meters per second. So if I'm listing my facts, I'm going to begin with a car is decelerated from 45 meters per second to 10 meters per second. So my original velocity is going to be 45 meters per second. So I'm going from 45 to 10 meters per second. So 10 meters per second would be what? The final velocity. So the final velocity is 10 meters per second. Over 4 seconds. 4 seconds is what? The time. So time is 4 seconds. So at this point, there are only two questions that they could ask me. What is the acceleration of the car during this time? Or what is the displacement of the car during this time? Those are the two questions because there's only 5 variables in straight line motion. VO, VF, A, S, and T. So those are your 5. So every problem is going to have 4 out of those 5. Well, in this problem it says, what's the displacement of the car? So the symbol for displacement, remember, is S. And so that's our unknown. So that's what I'm going to put as question mark. And I'm still going to put the unit. Now, sometimes they might say, what's the displacement in feet? Or what's the displacement in miles? And what would be different is this would be different here. But based on the numbers in my problem, I know I will get meters. So that is your step 1, listing the facts. Now, step 2 is to just pick the correct equation. You've got 5 to pick out. I think the easiest way to find the correct equation quickly is to say, what's the only fact that I did not write down here out of the 5? What's the only fact I didn't write down? Acceleration. So if acceleration is the only one that I didn't write down, then I'm going to pick the equation that doesn't have acceleration. Because if it doesn't have acceleration, it has those 4. And there's only one formula that doesn't have the acceleration, and that is S equals VO plus VF over 2 times T. So that's the formula that I would be using in order to solve this problem. Now, step 3 is to algebraically rearrange the equation to solve for the unknown. So if time was the unknown, I'd have to do algebra. If VO or VF was the unknown, I'd have to do some algebra. But the unknown happens to be S. And S is already isolated from everything else. So there is no algebra to do in this problem. Now step 4 is to just substitute and solve. Notice the formula itself already has parentheses. So what I'm going to do is I told you replace all your variables with parentheses. So since the formula itself already has it, I'm going to do this. I'm going to write S equals VO plus VF over 2 times T. So I set up my parentheses so that I can replace the variables with their values. And when I replace them, also make sure that you include not just the number, but also the unit. Because I'm not only getting a number, I also need to show that my answer does end up in meters. So plugging in the numbers, I'm going to put in 45 meters per second and 10 meters per second and in 4 seconds. Some of the mistakes I saw when I was looking at people do this problem is, first I saw someone in one of my classes put the 10 as negative 10. And I don't know whether they did that because the word decelerated was used, and decelerate means something slowing down. But if it's slowing down, if I'm moving in this direction and I'm slowing down, even if I'm slowing down, I'm still going in the same direction. So I might have been going 45 meters per second here, and then by the time I get here, I'm only going 10 meters per second, but I'm going in the same direction. So when your motion is horizontal, and this would be horizontal, a car driving horizontally, then your velocities will never be negative. The only thing that can be negative is acceleration when the motion is horizontal. Everything else will be positive. Now, once you get to this point, I don't want to see step four part A, and then part B, and part C, because the first thing you're going to do is put that together and then write 55 over 2 times 4. And then you're going to do 55 divided by 2 is a number times 4. Once it looks like this, you should be able to put this in your calculator so you get the right answer. Now, I saw two answers that were common. The right answer and a number of people got 200 meters as their answer. And I think that's probably because they did the stuff in the wrong order of operations. So if I'm doing this problem, what you should do is first go 45 plus 10 and make sure you hit equals. Okay, you have to hit equals after you go 45 plus 10. That would give me 55 in my calculator. Divided by 2 times 4 will give you the correct answer. This is what I think people, in fact, I can tell now how people got 200. 45, they put 45 plus 10. They didn't hit equals at this point, so when they divided by 2, the calculator only divided the 10 by the 2, which is 5. And 45 plus 5 is 50, and 50 times 4 is 200. So that's how people got 200, which was the wrong answer in this problem. The right answer would be what? 110. And so this number, that 2, and that 4 is where the 110 came from. And meters per second would be meters per second in here, times seconds. The second would cancel the seconds, and that's why the answer is in meters. So if you do the algebra right, you should get the units that you expect the answer to be in.